Hello, good morning, and thank you for joining for this session. I hope you all are having a lovely day too, and are already raking up a lot of steps walking through the maze that this conference is. But I hope that you continue to have fun and a lot of learning for the rest of the week. My name is Sujay Doshi, and I'm a senior product manager with Amazon GuardDuty. I'll be completing 4 years this February, and I'm joined today by Peter and Michele.
Hi, Peter Ferry. I've been with Amazon for 5.5 years, and this year is my 40th year in doing anti-malware research.
Thank you. I'm Michele. I'm in the bank in almost 3 years, and I'm working as a senior security engineer.
All right, thank you. So a quick agenda. We'll start with giving a short overview of what the service is. Just raise of hands on how many of you today use GuardDuty, and more specifically, one of the malware protection offerings. All right, okay, that's good. Next, we'll talk about the new feature that we launched, a couple of new features that we launched a few weeks ago. One is a scan-on-demand API, and the other is a fully managed offering to scan your AWS backups for malware. Next, we'll use Peter's extensive experience, and then for the first time, he'll actually dive deep into the inner workings of the GuardDuty malware scan engine, and essentially how we keep up with the ever-evolving malware landscape. And then we'll have Michele share on how they use one of the offerings or a couple of the offerings from malware protection from GuardDuty to drive their security outcomes at new bank. So GuardDuty, Amazon GuardDuty, for the ones that do not know, it's a native threat detection service from AWS, trusted by 95% of our top 2,000 AWS customers. Looking at data and consuming logs, essentially, GuardDuty for across tens of thousands of customers monitors millions, hundreds of millions of EC2 instances and millions of S3 buckets to essentially give visibility into account and resource level compromise. The sophistication that it derives is the accessibility to native threat intelligence that it collects from various internal threat intel groups and combining it with all the different detection algorithms that we use that threat intelligence to detect sophisticated cloud threats. One such example is with a system called Mithra that we run internally. It's a domain reputation service. It's a graph-based neural network database that essentially monitors all the DNS traffic across Amazon for the last 7 days and curates a list of malicious and benign domains. A lot of the times, days, weeks, months sooner than a traditional threat intel provider. And the reason we are able to do this is the accessibility and the telemetry that we are looking at to kind of build this intelligence. Being a fully managed service and being the first party service, automatically these IOCs in form of IPs, domains, and file hashes are consumed by GuardDuty into the threat intelligence platform that is then used to monitor the customer workload and the network traffic to detect those threats. The other example that we share here would be a system called MatPod that's a globally distributed system of threat sensors, honeypots, that's essentially tracking the attacker behavior, the tactics, the techniques, and the procedures, which ultimately also provides us the IOCs on and the behavior to understand on how the attackers are targeting the whole of AWS cloud that we can then leverage for specific customer workloads and then use it to generate findings. And then from an elasticity perspective or the auto-scaling aspect, we're just sharing an anecdote that this year during Prime Day, which I hope a lot of you were able to enjoy, GuardDuty processed close to 9 trillion events in an hour. Goes on to show with a 49% increase year over year on how automatically it will scale with the data that it consumes. With all this intelligence, it essentially relies on the telemetry and the sources that we collect the data from. And when you think about GuardDuty as an account that has enabled GuardDuty, automatically will be monitoring the CloudTrail management events and the VPC flow logs and the DNS query logs from your EC2 instances. That's basically what we call as foundational sources. And then everything else that we have S3 data plane events, Lambda monitoring, wherein we monitor the Lambda function executions for network threats. All of this and the runtime agent, all of this essentially are what we call as opt-in protection plans. So as a delegated administrator, you can decide to enable it on specific workloads where you pertain that the threat activity would manifest and you want to be protected against. Once we collect all of this data, and a key differentiator from a fully managed aspect perspective means that US customers, you do not need to do any source server-side configuration so that and then collect the data so that we can process it. You don't need to collect the data specifically for GuardDuty. It may be for any investigation or compliance purposes, but GuardDuty does not rely on customer vended logs. We automatically, if you enable one feature or multiple of these features, will automatically pull the data from a backend stream so that you do not have the cost of ownership of collecting the data and then shipping it to GuardDuty so that we can process it. And that's a key value proposition, being the first party in a fully managed service. Once we have all of this data, it goes to the analytics engine that essentially comprises of threat intelligence we talked about, some heuristics-based TTP detection algorithms, and then we also learn the normal behavior from these logs to essentially generate ML-based anomaly detection findings that gives visibility from the perspective of, is it normal for the organization? Is it normal for this particular workload? Does the communication happen from an ASN that has bad reputation? So on and so forth. But the major focus of this session would be on malware scanning or malware detection. Historically, when GuardDuty was launched in 2017 and up until 2022, we had all of these different protection plans or features which relied on telemetry data or events. But in 2022, we expanded to, for the first time, we expanded to scan a particular resource, specifically here to detect malware. So we'll talk about some of the offerings for malware protection that we have. Starting with in 2022, as I said, we launched for the first time malware protection for EC2 that delivers an agentless solution to detect malware for your EC2 and container workloads that have an attached EBS volume. With a single click, and similar to other features, right, the ease of use and holistic coverage across the organization remains paramount. With a single click, you can get malware protection coverage for all your accounts and workloads. There's centralized monitoring, so you'll have a delegated administrator and the security teams can essentially review the findings with contextual data around the malware family, the source within the scan engine that we use, and we'll talk about that later in the session. Then there's no agents to a very big value proposition here is that there's no agents, so you don't have to update, manage, install in order to specifically detect malware. The container awareness brings in a key protection against some of your container deployments, and if there's a malware that's installed. Prior to this feature, customers had to essentially take a snapshot of their volumes, run it against whatever malware scanner is at their disposal, and then try to stitch it back to a narrative around if you saw in GuardDuty a network anomaly that indicates that there's some communication to C2 server, what would a customer want to do, right? They'll take a snapshot, they'll check whether it's malware or whether a malware was installed as a result of this network communication. But all of that with this feature was automated with a single click. So customers who have enabled this feature automatically will have their EBS volume scanned when we see a preceding network anomaly. Or you can even use scan on demand as part of your investigation or forensics workflow. And this one, there's no performance impact to your live workloads because again, there's no agents that are installed. Next, we expanded the offering to provide a fully managed solution to secure the data pipelines that you build on S3, specifically helping to solve for untrusted upload application use cases. You have external vendors that's uploading data, or you have internal users that's uploading data to S3. In both these scenarios, you did not first want to be the receiver of something that's malicious, so that you want to establish a trustworthiness in the data that's uploaded to your S3. And also in the second case, you do not want your internal users through some, let's say, supply chain compromise, in the event that they are uploading, let's say, an image file, it's actually not a malware, and you do not want to be a distributor of malware. In both these cases, there's a massive need to ensure that there is trustworthiness in the data, and you can trust the provenance of the data that's being sent. With this feature on the buckets, you can configure the malware protection plan and will automatically monitor for any new objects that are uploaded. We'll scan them, we'll detect if it's a malware, generate a finding, use EventBridge. Using EventBridge, there'll be scan notification that you can consume either in the delegated administrator account or your bucket owner or the member accounts. But once we also complete the scan, we'll attach a tag on the object itself so that you can implement inherent protection and quarantine use cases. Using tag-based access control, in the bucket policy, you can ensure that no user or the application can access this particular object until and unless you find a tag that's clean, let's say. The scan engine, and again, we'll dive deeper into what all comprises within the scan engine, but that's automatically updated to keep up with the signatures and detection definitions that we'll be using to detect malware. So you, as a customer, you don't need to manage the infrastructure. There's no management of updating the scan engine to keep up with the latest and the greatest threats. And all of it is managed on your behalf through this feature. And there's seamless setup with your minimal configuration on the buckets that you want to protect from untrusted upload applications. A few weeks ago, we expanded the same offering. Everything's the same from a scan infrastructure perspective. You do not need to manage, again, no infrastructure, no scan engine updates. But we added another pattern essentially to ensure that you not only scan any new object uploads for malware, but you can decide to even scan existing objects within an S3 bucket to actually detect malware. And you can seamlessly integrate into your workflows using the API to ensure that even for the objects that are already existing, you can establish a security baseline for the buckets that are, let's say, not newly set up. And a hybrid strategy of combining continuous monitoring through new object upload scanning, and then retro scanning through objects that are already present in your S3 bucket to ensure that you have the latest and the greatest security baseline for the buckets that's in that untrusted upload realm. And again, the orchestration layer, you can use the API depending on what the operating procedures are and the workflow entails. A major focus of this session for the remaining part of at least my talk would be to introduce the fully managed offering that we expanded in GuardDuty malware protection suite of offerings is to scan the backups taken by AWS Backup for malware. We launched this a few weeks ago, and this is where from the AWS Backup console, as part of your backup plan, you can ensure continuous monitoring for malware once a backup job completes. We'll scan your EBS backups or snapshots, your EC2 AMIs, and your S3 recovery points automatically for malware once you set up that configuration as part of your backup plan. You can also use on-demand scanning and investigate your past backups, very specifically useful for safe restoration workflows. In addition to be scanning, we have two modes that are available, full and incremental. Incremental scanning here provides cost efficiency, wherein we'll only scan for the data that's changed between a backup that I took yesterday and the backup that I'm scanning today. So you don't end up paying for the entire scan always. But then the full scan is where you add more security assurance, and is something that you would want to ensure that you are safely restoring always with the latest verification from the latest and the greatest malware detection definitions. So the full scan gives you that opportunity. And again, the idea is it does not involve you as part of the backup processes. So the backup jobs, once they're complete, is when the scan initiates, and there's minimal configuration that you have to do either on GuardDuty or backup to realize this feature. And this eliminates the need for you to do manual scan and restore workflows, which are time-consuming, delays the business recovery, in cases and events like ransomware, and provides you a seamless integration between these two kind of native AWS services. But you might ask, on why would you scan backup resources for malware if you're already scanning the live workloads either through traditional EDR tools or using one of the offerings from GuardDuty that we talked for EBS volume scanning and your S3 object scanning. And to understand this, we'll try to look at a scenario on how a malware progresses through a backup. And this timeline is a typical 14-day retention timeline, wherein each block represents a daily backup. So as you can see in the first phase, which is the green phase from day 1 to 7, we see that the attacker already has a foothold in the environment. And, but again, the malware was planted, but it's dormant. It's not yet activated, right? We don't see any system changes. There's no files that are impacted. We don't see encryption, or there's no malicious artifacts that got introduced in day 1 to 7. Also, the dormancy of the malware ensures that there's no persistence that's created, and it's just specific malware files that are present, but they are not yet acting upon. Also, the reason we call these backups as clean backups is in a typical restoration workflow, you'll always restore, or you want to restore in a clean and isolated environment. What that does is, it actually, in many cases, negates the effect of the malware, which is environment dependent, right? And it also blocks the C2 communication pathways. So all in all, this represents the safe recovery period and also a point in time before malicious behavior is surfaced in the environment. The second phase is the yellow phase, day 8 to 10, where we start seeing early stage artifacts appearing in the environment. This might be small preparatory changes, but are still low noise that your in-environment EDR tools or live scanning workload solutions will actually not have noticeable indicators that are generated because of the low noise and still the dormancy of the malware. But all of these, once the malware is activated, actually that slips past into the backups. You can still do some surgical fixes from this malware and restore just the critical business data, but that is where you still need to perform the item level recovery capability that AWS Backup inherently provides, ensuring that you are restoring just the clean portion of these backups. And day 11 to 14 represents where we see ransomware event happen. So the entire production system and even your new backups that are taken are actually all compromised, and it's unsafe to restore from these backups. If you think about this timeline in a real environment, the timing spans across multiple weeks. For an example, if the initial compromise that we talked about happened 3 weeks ago, your last clean backup that you know of was taken 2 weeks ago, the activation happens now. So imagine that by the time the team identifies that there's a breach in their environment, it might be too late because of the retention window that you typically would have configured for your backups, and you start losing on the clean backups. Imagine if you identify the breach 1 week from now, you're basically losing out on the entire safe recovery window or the backups that are identified and tagged as clean backups. So the key takeaway here is proactive preservation of the clean backups, but more importantly, identification that you have a clean or an infected backup to ensure that your recovery process in the event of events like ransomware, you can safely recover always from a clean copy. So this progression actually highlights a natural blind spot and the early stage threats that slip past into the backups but are not detected by live workload scanning solutions like GuardDuty, EBS scanning, or S3 scanning, or even your traditional EDR tools, because they are not designed to actually detect some of these dormant behaviors. They'll be monitoring the in-environment running workloads, and then we'll look at the behavior in many cases to find something malicious has happened. And if the threat is dormant, which in our example was the case, these threats will slip past into the backup. Automatic backup scanning essentially solves or addresses this by continuously scanning the backup data at rest into the backup repositories, abstracting vault level constructs so that it automatically, once the backup job completes, will initiate the scan. And it continuously tracks the changes that happens to your backups and identifying from when a backup moved from clean state to unsafe to actually compromised. And then you can define the last known clean backup is what you want to restore from in the event of ransomware. Also, the traditional recovery solutions actually rely on manual restore and scan, which is, again, as we identified, is time consuming, adds cost, overhead, and delays essentially the business recovery. So automatic scanning through this feature basically solves for these efficiencies and will continuously provide assurance of the presence of malware as the backups are taken. All in all, bringing this together, backup scanning essentially provides a second layer of defense to your traditional malware scanning for live workload solutions, and hence they are more like complementary and not competing solutions, which are two essential security layers in the entire data protection lifecycle. Quickly, we'll look into the importance of periodic full scan and how you want to ensure that while cost efficiency is a major factor with incremental scanning, but time and again, and especially for safe restoration, how full scan and more specifically periodic full scans are important, right? So imagine the first full scan happens on the day one when the backup runs. So day 1 to 4, after the first backup, there's incremental scan, and we'll continue to scan just the data that changed between these days. Let's say a zero-day malware was planted on day 4, but GuardDuty, because at that point the detection definitions did not have information about that threat. So what we'll do when we'll do incremental scan, we'll actually tag it as no threats found. Even though the threat exists in the backup, when we scan that data, because we didn't have the detection definitions, we'll tag it as no threats. So now let's say after the 5th day is when the malware engine was updated and we now have that information of the zero-day malware. But if you continue to just run incremental scans, because it only scans the data that's different from the past day, we'll actually continue to attach the wrong disposition to subsequent backups, and we'll continue to tag them as no threats found. So where periodic full scans come into play, for the same scenario, on the if on the day 6 when we identified that there's no threats found, let's say on day 7 you actually ran a full scan. Now because you already have the information with the latest detection definition and also the definition for the zero-day malware, we'll actually attach the right disposition. We'll say that backup 7 it has threats, and we'll also maintain the lineage of all the backups attached, or the parent backup from which then we continue to take incremental backups. So once you rebased the baseline through periodic full scan, when we do an incremental scan on the 8th day, even though there is no new file that was added, which was actually malicious, we carried forward the status. So tomorrow, if you decide to actually restore from 8th day backup, you will have the information that in the lineage, there was a backup that was either the same backup or the backup in the lineage has malware. So once you remove that malicious file from the backup source, your subsequent incremental scan automatically will rebase the status. So now what this provides is it maintains the information and the history of through incremental scans, it will maintain the history of what files that were detected as malware. Are they still malicious? And if they are, we continue to carry forward the status. And if we don't find that malicious file and everything is clean, we'll update the status so customers can use these subsequent backups or the last known clean backup. This is the importance of periodic scanning to ensure assurance every time you want to restore. A sample implementation workflow, think about using GuardDuty, you get to the point where there's an outcome in form of findings, there is event bridge notification. You can use that and have custom implementation through a Lambda function, let's say, that will tag the backups and use SCP to ensure that you are never restoring from a backup that's tagged as infected. On the other hand, for clean backups, you can safely move them to an isolated environment to ensure that you always restore from these isolated logically air-gapped vaults to make sure that the backups you're restoring is safe. How it looks on the console, you simply provide a scanner role as part of your backup plan, define which resources you want to perform the backup scanning for, and then you select the mode against the cadence of daily, hourly, weekly, monthly. And then the on-demand scanning is exactly the same, wherein you provide for investigation or forensics, you provide, and you can perform full-on incremental, but you provide the ARN, and will continue to scan, providing you have the right permissions given in the role. And then on GuardDuty, you can monitor the results. Again, contextualization, like any other finding in GuardDuty, is paramount. We'll give the malware source information, the scan engine information, so on and so forth. And again, if you want to restore, as part of your backup processes, you go to the backup console, and then you look at the backups that are clean, and then you can define to either run an on-demand scan. We actually recommend to run an on-demand scan always at the time you are restoring, so that it verifies against the latest signature set to give you the assurance that you need. Pricing, straightforward pricing for all the resource types, that is EBS, S3, and EC2, 5 cents for the GB. If you decide to do incremental scanning, the first scan will certainly be a full scan so that we can then define on the next time a backup is run what has changed. So the first scan will be full, and then subsequent will be incremental depending on your configuration. And there's an example for 100 GB volume, it will be $5. And then subsequently, if there's only 2 GBs that changed, it will be cost efficient, giving you kind of the same results that you'd reach to, or outcomes you'd reach to with full scans. So some general best practices: automated incremental scanning for cost efficiency, periodic full scans for rebaselining and assurance. And like I said, in time of security incidents for restoration, on-demand scans always appreciated. And you don't need to enable foundational GuardDuty, but we still recommend it, right? Think of different solutions and findings that we have, especially for resiliency and recovery and ransomware detections, which is not always based on files, but fileless behavior you see with S3 data plane events, where we see a lot of encryption through customer keys, or there's a spike or anomalous spike in get object, list object kind of scenarios. All of those signals and findings are available in GuardDuty through other features. So even though foundational GuardDuty is not paramount, but we recommend it so that you can combine it with these signals to get higher fidelity findings around your ransomware events. And with all the information that's available in findings and event bridge, both backup persona and security persona get the relevant information around the malware. All right, I'd like to invite Peter to talk and dive deep into this.
So GuardDuty has multiple engines that it uses to handle different detection scenarios. The first engine we have is a hash-based one. And we use that engine primarily to suppress false positives. So we can exclude the one file and no others. We also use this engine for responding quickly. For example, if there's an outbreak, and we can add detection very quickly, and we can respond within minutes instead of hours. The engine itself is quite fast. We found some ways to accelerate our hashing operation. And the engine itself is resilient to minor changes in the file. And what I mean by that is that typically we consider a file to be a solid block of bytes, and to hash just from end to end to get a single hash. But there can be cases where a file has instead of being a solid block of bytes, there might be some squishy bit right in the middle. It might have a URL or username password combination. And in that case, our engine is differing from the traditional implementation because it can be told to hash around the variable part. Similarly, if a file has content at the end that is variable, perhaps there's an appended configuration, then our engine can be told to hash up to the point where the variable content starts, which means that you can add any number of additional bytes, you can change any values within the variable section, and we'll still have a constant hash. So for the people that, bad actors that are getting their sites taken down quickly and they keep cycling, we'll still have detection for these. The next engine we have is a pattern matching engine. In the event that hashing is not suitable because there might be multiple changes throughout the file, or if a file is very, very large, but the really interesting part is right at the front, then we'll use the pattern matching engine for that. The engine is very flexible. It supports traditional signature-based scanning, just doing straight byte comparisons. But we can do more than that. We can perform conditional evaluations up to a certain point in the file. We can perform frequency analysis of the bytes we've seen up to a certain point. And we can even extract bit-level characteristics of the file for very fine-grained pattern matching. The engine is very expressive, so the intent of a detection is very clear for the next engineer who has to perhaps extend an existing detection, or if they're the ones having to do the code review for an existing detection. We use this engine primarily for specific detections where the code is constant across replicants. And here's an example from actual malware. This code will execute arbitrary commands received remotely without any user interaction. And for us, this is quite a simple example. It's a single detection. But there also can be cases where we want to use the engine for generic detections, where multiple variants of the same sample differ only slightly, but are otherwise functionally equivalent. Here's an example of an actual malware, just a snippet of the code. This malware uses a polymorphic engine to change its appearance from replicant to replicant. And the engine is able to insert random characters in the decryptor body and also change the variable names to random strings. Here's another example where you can see the constant portions are becoming smaller. And here's an extreme example where the constant portions have been reduced to the smallest possible length and all the variable names have been replaced with random strings. And despite the difference between the first example and the last one, it's still a single detection for us. It gives a sense of just how powerful this engine is. The next engine we have is a machine learning engine. And our focus with machine learning is cryptocurrency miners. The reason for that is because within our environment, cryptocurrency miners are a big problem. And you might be wondering how big of a problem it is. If we look at this table here, we can see how quickly a cryptocurrency miner can be installed. We went from a misconfigured state to a compromised state in less than 4.5 days, which means that the the compromised instance was found in its pristine state almost immediately, and the miner was installed very, very quickly after that. If we consider from a dynamic analysis point of view, over 60% of compromised workloads involve cryptocurrency mining as part of that post-exploitation event. And in fact, cryptocurrency mining is the most common post-compromise activity that we see in a dynamic detection scenario. But coming back to the static analysis, I took 1 week's worth of scan results that had detections. Of those scan results, I took 8,000 samples entirely randomly, and of those 8,000 detections that we had, 45% of them were cryptocurrency miners. Now, not all of those were unique, but even if 90% of them were identical, that still leaves over 300 unique samples that someone would have to add detection for manually from this subset week over week if we were to do this one at a time. So that's a huge problem. But fortunately for us, we have a machine learning model, and I would love to say it's so awesome that it detects all of these, but it's not, at least not yet. But still, it's doing some very heavy lifting for us. And for the ones that it doesn't detect, we have our pattern matching engine and the hashing engine to clean up the rest. The next engine we have is a third-party engine. We receive this engine as an SDK from the vendor, and it runs as part of our regular scan flow. But we run this engine in an entirely isolated instance. It's not able to connect to the cloud provider. It's not able to connect to the internet at all. The only thing we get out of the instance is the finding results, and we are very careful about what we will accept from the finding results to minimize the chance of exfiltration of data. We use this engine primarily for historical detections because the vendor has seen many samples that we might never see. We don't automatically collect samples from customers, and we don't share these samples with the vendor. So in the event that a customer is not willing to share a sample with us, then we might never see the sample at all. The SDK also offers heuristic detections, and they use a machine learning model for this as well. We are working to develop our own heuristics specific to our environment, but at least for now, the existing heuristics are a very powerful baseline for us. We also get parsers in this SDK for common file formats, such as archives, images, and documents. Again, we're working on our own parsers specific to our environment to get better scanning performance. But we also have file formats that the vendor might never see because we don't share the samples. And so we're working on specific parsers for those too. So that covers our static detection for EC2 and S3. And Michaeli, my co-presenter, will talk more about a specific use case for S3. But we have more than just static scanning. We also have a runtime service. This runtime service runs on the instance. It has system-wide visibility into everything that's happening as it happens. We get file system and network events, and it's also container aware, so we can see inside EKS and ECS. We collect events from the system into signals, and a collection of signals get correlated into a finding. Here's an example of a finding using our latest extended threat detection, which was presented at an earlier talk this morning. You can see the level of detail that we have here. We have a detection here for a newly downloaded file. There was a file system event when the file was downloaded that triggered a hash calculation and a hash lookup. The hash was found on our deny list and resulted in this finding. Here's what findings used to look like, and you can see why we changed it. If you squint in the top right-hand corner, you can see a reverse shell was created on the system. We have file system events when the file was created. We have the system event when the process was started, and we have the network events when the process connected to the website and when it redirected the standard I/O to point to a particular port on the system. And that collection of events resulted in this finding. Here we have another detection for a site that tried to connect to a cryptocurrency website. And the network event that was intercepted when the process attempted to connect to the site is what resulted in this finding. But for customers that don't want to run a runtime service on their instance, we have a network level scanning as well. And this is not relying on explicit scanning, it's just monitoring the activity as it happens. The network scanning is able to watch for network connections to sites with poor reputation. It's able to detect credential use in anomalous configurations. And it's also looking for data access that is not within the typical behavior patterns on the system. Here's an example of a finding where an instance tried to connect to a cryptocurrency website. Here's an example of a finding where an instance tried to connect to a command and control website. And finally, here is a finding where an IP address that's on our deny list attempted to call an API that is commonly used just prior to an exploitation attempt. And we see how this shows how all of our engines work together to protect customers, and that's how we keep up with the threat landscape. And now I'll pass to Michaeli, who can describe a specific use case for S3.
Thank you, Pete. So I'm from Nubank's cloud security team, and I'm going to present a use case from EC2 and EC3 of batteries malware module. But before this, let me start introducing us to you. Nubank was born from the discomfort and the powerless feeling while dealing with bureaucracy in financial services. We started in 2013 in Brazil with a goal of simplifying people's lives and empowering them financially. Since 2013 to today, we went from a credit card issuer to the most valuable brand in the country. Seeing how successful we were, we began to search another markets and seeing how similar problems Latin America have, we started there. And now we have presence in 3 countries, in Mexico, Colombia, and Brazil. We surpassed our 100 million clients goal. And we still managed to have a metric of customer-centered philosophy to have less than $1 cost to serve each client. About the challenge that I'm going to present here, as Nubank was scaling and adding more financial products and more countries, we began to have a problem with rapid growth and also different regulators with specific countries. And this year, we had the opportunity to have a single process for PCI because it's basically the same in each country. The main point about the PCI that I'm going to present here is about malware detection. And not only about the requirements that we were going to attend, we also had the company's requirements. Our security team don't have to impact or add friction to growth. So we were searching a tool that could be effortless to integrate in our system. And GuardDuty was the smoothest and most integrated with our environment. To begin the implementation strategy, I have a main point to present here is Nubank. In Nubank, we treat each country as a single organization in AWS. So if we're gonna do the configuration of GuardDuty on AWS organizations, we would have administration points for each country. And as a global team, it's simpler to go into with an invitation-based implementation. It's showed on the step 3. But in practice, we have the accounts with the resource in the original place and going further to our administration point. For the monitoring of findings, we have a dual path. As a cloud security team, we have to enable things from other security teams and have this monitoring constantly. The main path and the official path for the CERT and SOC teams for incident response is the one that goes through a bucket and feeds our CM so they can interact. And the other path serves a purpose of visibility and also that we can be promptly ready to have any assistance for the security teams and the production teams invited in the incident. Beyond the implementation of the detection, we also managed to get ready for, specifically for S3, the whole process automated with a fast response, where we can be a tag-based pipeline once GuardDuty tags a S3 object. We managed to have a restrictive policy, so only SOC teams have interacting with the file and had the analysis. If they marked false positives, they also update and the access is restored. For the EC2, we went from a more conservative approach because in our automated first response could lead to outage. So we made available the isolation in the playbook, but it's only applied once the team is involved in the incident. So to finalize our use of GuardDuty, we begin with a regulator request. We managed to revise our process of malware analysis in the bank and also improve the process. Because we use GuardDuty in our already integrated environment, we caused no disruption to productive teams. We didn't break anything and was very seamless. We also achieve a global compliance and we can roll out to any country that we intend to. This changed completely our coverage in the cloud because we didn't have this to S3. And also, by enabling this, we managed to get to productive teams a new feature. They can autonomous enable a document triage for third-party files and be more secure. The whole process was revised and enabled in less than 2 months, and we still managed to maintain the cost less than $1 to serve each count. So welcome back, Sujay, to finalize.
Thanks, Michele. All right, so some key takeaways from this session that we learned. The fully managed aspect reduces the cost of ownership for you to detect threats from malware in your workloads, and more specifically, aiding in ransomware scenarios with the recently launched feature. And again, live workloads, and you can combine now with backup scanning or for backup workloads with a single scan engine that kind of learns from all of these different offerings to collectively provide higher efficacy and higher fidelity to malware-based threats. And it complements, as Peter walked us through, it complements other offerings from GuardDuty by combining and correlating to actually provide visibility into the actual breach scenario, pre-exploitation, compromise, and post-exploitation. And this improves security operations with contextual information around the resources, the malware family, the scan engine that contributed, and the attacker information. And that's it. Thank you for attending this session. I'd like to invite the fellow speakers to